Okay, so chapter 5, number 20, we'll do a couple parts. Um, so we're proving trig identities, and the general idea is you want to start with a complicated expression. In part C, I don't really think either one is more complicated than the other. Um, and then you want to just simplify it as much as possible, see if you can get it to look like the other side. If you get stuck, good rule of thumb is switch everything to sines and cosines. In this case, we're already there. So hopefully these work out reasonably well. Let's look at C. I'll just start with the left side, mainly because I don't like complicated denominators too much. Um, so if you notice on the right side, I somehow have to get a cosine in the denominator. So might as well introduce it early on. So formally, you got to start with one side only and then write equals. So even though I'm going to end up rewriting it here before I multiply, this is what you need to do in order to show me that this ends up equaling the thing I'm going to write at the end. Okay, so if I multiply this by cos b over cos b, that's how I'm going to get that 1 cos b in the denominator. Okay, so if I write this out now, I've got cos squared b over cos b times 1 plus sine b. I keep saying b, but really it's beta. Um, well, let's see. What can I do here? Somehow I have to get rid of the 1 plus sine beta, and that means I'm going to need some sort of sine beta on top. So cos squared is the same thing as 1 minus sine squared beta. Actually, I don't need parentheses there. Because remember, sine squared plus cosine squared equals 1. So cosine squared has to be 1 minus sine squared. Remember, it's useful to think that way too. So this is going to be 1 minus sine squared over cos beta, 1 plus sine beta. Well, if you think about 1 minus x squared, that's the same thing as 1 minus x, 1 plus x. So this is the same thing as 1 minus sine beta times 1 plus sine beta. All over cos beta, 1 plus sine beta. Well, this is good because now I can cancel these guys, and I'm left with 1 minus sine beta over cos beta. And to make this fit, there. Now it's in the circle that I put there before. Okay, so that's part C. Let's look at E. Notice again, you start with one side, you have a string of equals that leads you finally to the other side. That's the proper way of doing these things. You can work from both sides if you want it. Maybe you work from this side to about here. You work from this side till you get to there. But in the end, your final answer has to be arranged where you start with one of the two sides and work it in a linear way all the way to the end. Okay? So in E, this one's a little tricky because it's got fourth powers here. But the fourth powers really, let me show you this trick. So if I have x to the fourth minus y to the fourth, you can really think of this as a squared minus b squared, where that turns into a plus b, a minus b. But the a and the b are really x squared and y squared. So if you think of this, it's the same thing as saying x squared squared minus y squared squared. That's what this is turning into. Okay? So instead of x, it's cosine, and instead of y, it's sine. So this thing right here, I'm going to write that out. That's the same thing as cosine squared x squared minus sine squared x squared. And if I do this, it's something squared minus something squared, right? Just like I've got something squared minus something squared. So that's going to turn into the first thing plus the second thing and the first thing minus the second thing. So the first thing plus the second thing is cos squared x plus sine squared x. And the first thing minus the second thing is cos squared x minus sine squared x. So, if we look at this, somehow I have to end up with just cosine squared minus sine squared. But the nice thing is, that right here is 1. Remember, because sine squared plus cosine squared is always 1. So I get 1 parentheses cos squared x minus sine squared x, which just turns into cos squared x minus sine squared x. And I've started with one side of my equation, the slightly more complicated looking one, and ended up with the other side at the end. It turns out there's another problem somewhere in the homework that has you go another step beyond this. That turns into cos x plus sine x, cos x minus sine x. But in this problem, you don't actually have to go that far. But I think this is the solution to some other homework problem in there. Okay, hope that helps.